So here's my concept map. I began with inorganic chemistry, which is the study of inorganic compounds. All compounds are made up of atoms. Atoms are measured in units of Daltons. So, with atoms, we have protons, neutrons, and electrons. Protons are equal to the atomic number. Now, protons and neutrons are in the nucleus, while electrons float around the nucleus in electron shells. The outermost shell contains the valence electrons, which are usually the electrons that are transferred. So, electronegativity is how strong an element attracts electrons. And on the periodic table, the more right you go on the periodic table and the more up you go denotes electronegativity, making fluorine the more electronegative element. Now, the transfer of electrons in reactions are the redox reactions, and electrons are either accepted or donated. Now, substances that accept electrons are acids, and substances that donate electrons are bases. And when you have reactions between acids and bases, usually a salt forms. Now, acids are measured in strength by the pH scale. The lower the pH, the more acidic something is. Now, going back to atoms, all the sum of its constituents, the protons, neutrons, and electrons, is the atomic weight of that atom. And then you get molecular weight from the sums of the atomic weight in that molecule. Now, molecular weight is donated by moles, and 1 mole is equal to 6.022 times 10 to the 23rd power particles, which is Avogadro's number. You can measure molarity using moles. Molarity is the number of moles in the solute over the liters of solution. And liters is a basic unit of measurements to measure volume. Grams is a basic measurement to measure weight or mass. And meters measure length. And millimeters is 1/1000th of a meter. Now, from atoms, we get elements. Elements have they form different types of bonds with one another. We have polar covalent bonds, non-polar covalent bonds, double covalent bonds, triple covalent bonds, ionic bonds, and hydrogen bonds. Now, non-polar particles sometimes have hydrophobic interactions, which is it not wanting to bond with water. Hydrophobic literally means fear of water. So like oil and water, they don't mix together. That is a hydrophobic interaction. Now, the elements given were potassium, calcium, sodium, chlorine, phosphorus, sulfur, oxygen, hydrogen, nitrogen, and carbon. Now, speaking solely on hydrogen, hydrogen can become protonated, which forms the hydrogen ion. It's a positively charged hydrogen, which is a cation. Cation is when an ion is positively charged, and an anion is when an ion is negatively charged. Now, when you combine oxygen and hydrogen, when you have two hydrogen molecules and 1 oxygen molecule, H2O, you get water. Water has specific properties because of this hydrogen bonding. Water can either be cohesive, which is its ability to bond with one another, to stick to one another, or it could have adhesion, which is its ability to stick to a surface. Now, water can become protonated just like hydrogen to form a hydronium ion, which is H3O. Water also has different isotopes. An isotope is when it has a different shape but the same formula. And then you have isomers, which is the same thing. It's when a specific compound has the same formula but different shapes. Now, a radioactive isotope is when it has a different mass. So it's either has more protons or so forth. So the mass or the formula is going to be different from the original element. And the time it takes for it to go back to that original element, the original form, is a half-life. So carbon is a special molecule in that it has an entire study around it, which is organic chemistry. Is the study of organic compounds. And in organic chemistry, you have functional groups, which is basically carbon, is how carbon is bonded to different things. For example, the functional group of alcohol is when carbon is bonded to OH. Or you have methyl group, which is carbon bonded to 3 different hydrogens. Or amines, which are carbon's nitrogen bonds. You also have phosphate groups. Phosphate groups are when phosphorus is bonded to 4 different types of 4 oxygens. And phosphate groups and nucleotides are created by phosphate groups, which also creates nucleic acids. We see nucleic acids in our DNA and RNA. DNA means deoxyribonucleic acid, and RNA is ribose nucleic acid. So also from the functional groups of amines, you get amino acids. And long chains of amino acids are proteins. Now, carbon, oxygen, and hydrogen form different things depending on how they're bonded together. They can make lipids or they can make carbohydrates. With lipids, we have different types of lipids. We have saturated lipids when there are no double bonds, and unsaturated lipids when there are double bonds within the lipids. Now, another bond formed with lipids is phospholipids. Now, phospholipids are when phosphorus is bonded to a lipid, and you also have fatty acids from lipids. Now, from the same carbon, hydrogen, and oxygen, we can get carbohydrates. Carbohydrates are just sugars. We have monosaccharides and polysaccharides. Monosaccharides are simple sugars, where polysaccharides are long sugar chains. And when you combine sugars and proteins, we get glycoproteins. Or when you combine sugars and alcohols, we get glycerol. And that's it.